Hello, so this is my quick explanation of RAG projects that I created, and the purpose of it was to usage of like multiple PDF files, not just one. And I was using, as you can tell, LangChain and Llamaintex. In terms of models, I was using Gemma-7b, which is the model provided from Google. This is free, and I was using Hugging Face for it. And beside this, I was using GPT models for the rest. And I will quickly maybe show the PDF files, and if they load. Okay. So each of the files has at least few hundred pages, and this is 662 pages. So they are quite large files, and they're like PDF books. And yeah, I will start from sub-document summary technique. And so this is the standard RAG technique. So we're having our additional documents, we're chunking them. That requires embeddings, which are further stored in usually in vector database. In my case, it will be vector database. And then there is like user question query, which will be also embedded. And those embeddings from like the documents that we have from our like dataset, plus the user query after embedding, we need to find like similarities, which will base on like the vector similarity. So after finding the relevant documents based on the user question and the similarity of embeddings at the end, uh, the relevant document chunk will be passed further to our large language model, wherever we will choose. In this case, it will be GPT 3.5 Turbo, and LLM will generate answer for the user based on those. And so the classic approach before the subdocument summary, which I use here, was that we splitting entire document or documents into chunks, then embeddings, as I says, and further store in vector database. The later enhancement for these techniques was document summary. So we were providing summary as a metadata for every embedding. And so each embedding, there are like multiple embeddings for the chunks, store the summary of like entire document. And that was passed to database and a vector database. And searching is always like a reverse process. So first looking for relevant document summary, then fetch relevant document chunk, and generate a response from LLM. So let's start. So first, after installing all necessary packages, so my approach was to get those PDF from a Google Colab because I was storing them. So this is the code for connecting to Google Drive. You also need to have key for OpenAI, in this case, if you're using GPT. So this is something that will be provided for you from OpenAI website. I store my key in this function, which is on my drive, so I don't want to share it here. So that's how I'm getting it here, basically. But yes, and then I'm taking my PDF files, which are here, 3 of them. And to speed up the process of like fetching data, I want model to be able to fetch these data, these PDFs files from straight away from the Colab repository. So to do that, I'm creating the directory here, and then I'm just simply copying every file from here, from the data to specific data directory in the Colab, which I done already, so I won't repeat it again. And so simple directory reader. It will read the document and split into smaller chunks. So this is like important part because not every reader is able to read multiple PDF files. And here I'm just printing out the list of all available models from OpenAI. So you can see GPT-4, for example, there is GPT-4o, the latest one, and so you can pick one of them. And here we're coming to the subdocument summary, which I'm going to use in this example. So the aim of this is to split entire document into smaller subdocuments. So here you have, imagine this is the entire document, so you're splitting on, in this case, like 2 subdocuments. It will be more in like larger text, and you tuning it as a hyperparameter as well, and so on. But for this example, you have 2 subdocuments, and then you're giving the summary of these subdocuments. So you have your chunks. So this chunk number 3, based on summary of subdocument, will belongs to like this and this part. And so the reverse process, as I said. So we will be looking for summary subdocument, then we will get like the relevant chunk from this text. So it will give a more accurate response, or will increase the probability of retrieving the data that we are interested in, assuming that our data set include these informations that are that user is looking for. So this is the subdocument summary pack, and so yeah, defining the size of parent chunk. So this is the big chunk. These are all default. I didn't play with this, but yeah, as I said, these are like hyperparameters, so you can play with them. And this is the chunk size for the smaller chunks within subdocuments. I'm using GPT 3.5 Turbo because it's cheaper than GPT-4, and I'm very happy with performance of this model. So I was mainly using this, but I was playing with for GPT-4 and 4o as well. For embeddings, in this case, I was using OpenAI embeddings as well. And after having this subdocument summary pack and embedding our RAG and store it into vector database, we can generate the query, user query. So I was passing it as a string. So for example, what are conflicts in emotions and how to overcome them? So this is the initial response based on this code here. So you can read this if you want. And here is the source, neuroscience, psychology. And this is one of the, second PDF. And here I just wanted to make output more readable. So I created this function and it's the same. But I was also interested how these models will deal with different languages. So for example, this is in Polish, which means tell me something about emotions in psychology. And it was able to give response. And you can find it in another PDF, which is here. So this is second file, LangChain multiple documents retrieval using ChromaDB and OpenAI, where we will save our embeddings in ChromaDB into zip file so we can reuse it further. So after installation and importing all necessary libraries, this is just simple response wrap function that I wrote to make output more pleasant. And this step is identical to what I just explained. We want our key, and yeah, as I says, just pass here the string from your OpenAI key here, and it should work if you paid for access to it. Yeah, going further, exactly the same until here. So we're copying all the files into Colab. And in this case, for the loader, we're using PyPDF directory loader, and in order to load all the PDF files, 3 in our cases. And so it's splitting into the chunks which we are defining here, the size. So the number of chunks in this case for all 3 PDFs is 3,308. And this is just one of the sample of the chunks, which is here, page 7 from this document. And here we're creating our database. So we could store it or our vector stores and embeddings over there. And for embeddings, we're also using OpenAI here. And this is our ChromaDB here. And here we have Retriever. And from this, we can create our user query, which in this case will be this. So by default, it will return the 4 top relevant documents. So we can change it. So I change it to 2 top most relevant documents instead of 4. And you can see instead of 4, now it will be 2, which I will show later. again, just to see all the available OpenAI models here. And yes, so for creating the chain, we're choosing our model. So again, GPT 3.5. I didn't change the temperature in this case. So this hyperparameter, if you don't know, it's vary between 0 to 1. So 0 is more deterministic, and it won't give you, it shouldn't generate like more randomized answers, and it will be opposite if you change it further closer to 1. And yes, so this is the query. And this is the response using the response wrap function on top. So it just wrap, and you see the sources of this. And this is just the output, which is like messy without using any wrap function or anything like that. So the top answer will be somewhere like here, and then document will be probably the second one will be here, which is interpersonal communication. Yeah, it's very messy, as you can tell, but wherever you can see sources for both top two documents. So this is the first source, and second will be somewhere here. Yes, it's here. So to see, I just wanted to see what is passed to the chain as a template. So you can see that the template consists of this information. Use the following pieces of context to answer the user's question. If you don't know the answer, just say that you don't know. Don't try to make up an answer. Okay, here we creating zip file. So our database will be stored in under this directory as a zip. Just to make sure that it's working, I was removing it from Colab environment, and now we can like to verify it. You have to like restart runtime in Colab, just get OpenAI key from top of this file again, make all the imports from beginning of the notebook, and execute response wrap function. And here you unzipping the ChromaDB, and this step is as before, using OpenAI embeddings, search key arguments for top two from our vector database that we just unzip, using the same model, all the same hyperparameters, and you can see it works. So this is another query. What is genesis of abnormal behavior? Answer source is different PDF. And again, something in Polish, tell me something about emotion in psychology. In this case, the answer is actually given back in Polish, and yeah, you can obviously tell to answer in different language. That's not an issue. And again, different source, so it's actually proving that it's looking in all the three PDF files that we just provided. And yeah, this is again just the prompt template as we've seen before. So I will just quickly go through last two documents. So difference in this, the main difference is after all this step is that I was using different PDF loader. So this one in this case, and all the other steps are pretty much the same and or similar. And yeah, we having our queries here, answers based, that was response query was passed to our function, and responses given from different files. And the same works in different languages. The last one is different because I was using Gemma-7b from Google. And after installation, which is tricky because they're changing libraries, so you need to watch out for it and adjust it if it won't work. And so you don't have to install a lot of libraries also related to Hugging Face, because in this case we're using both the model, which is like the Google Gemma, but it comes from Hugging Face, as well as embeddings are coming from Hugging Face as well. And so directory reader, it's here. Yes, for embeddings, we're using this model, fast embed. This is system prompt. And here it will ask you to provide the login key from your Hugging Face, because you should obtain it before. I also store it like before, and I'm just like retrieving it from like the second index from my array. So here we're setting up the chain. As I said, it's Hugging Face, our model. And so for the output, I was using two versions. So if you want to do it like in traditional way, let's say skip these two. If you want to use Gradio, then execute these two and then go like later, skip these steps here. But you can see the answers here and another like wrap function for the text. And oh, yes, so this is quite important. So I was trying to ask in different language, but it was always like unable to give the answer. Here is the using the Gradio. Here are some outputs that I actually make like screenshots from it, where it was able to answer my questions. But the problem with this model is that in many cases it was unable to give me response. It just didn't find it. So on top of that, this model uh, takes like a lot of time to like generate your response. So if I want to like deploy it like further, any of these, I would definitely didn't use this one, because I had many problems with this, and uh, it's just not so good as even GPT-3 model. And that's it. Thank you.